All right, 15.4 homework. State A, B, and y-intercept and graph the function on a graphing calculator. So this is pretty straightforward here. We're going to go to problem number, I believe it is, yeah. Okay. So what is A? A again is our zero term. So in this case, A is 7. B is our common ratio, which is 0.9. Since that's less than 1, that means this one would be going down, be a decreasing function. And then what is our y-intercept? Our y-intercept is the point 0, 7, because it's our zero term. It's the same as our A, so that's our y-intercept. Very, very easy, just identifying aspects here. Okay, same thing, state A, B, the y-intercept, and graph the function and describe the end behavior. Okay, so this time they actually want us to graph it on a graph. So we'll do that here in just a second. Let's go ahead and do our A, B, and all that again. So A is our zero term, which is 5, which is also our y-intercept. Okay, so that's the 0.05. And then our B here is 0.6. So again, this one must be going down. Now, what I'm going to do is I'm going to type that function into my calculator. So I'm going to go to y equals 5 parentheses 0.6 raised to the x, then go to my table to get points. And what I want to do is I want them to fit on this graph, okay? So I'm going to look and see where I can start plotting points. And the first one I can plot is at -1. -1 is 8.33333, so 8 1/3. So -1. And you got to kind of pay attention here to values, how this scale is set up. So what do I mean by that? If we look, this is 1.5, 3, 4.5, 6, 7.5, 9. So at -1, I mean, we're just guessing here where that would be. -1, 8.3, so I'm going to say something like that. Okay. Then I look on there, 0, 5. 0, 5. So in theory, that's what this extra line is. Oops, go back. That extra line right there, that's supposed to be 5 to help you kind of plot that one. At 1, it's 3. At 2, it is 1. Oops, I made a mistake. Here's 1. 1 is at 3, sorry, because they're going by halves here. At 2, it's 1.8. Okay, so 1.8 would be maybe something like, because it's 1.5, maybe like right there. Move that over a little bit. There we go. Okay, and then let's see, at 3 it's 1.08, so that's going to be, I don't know, somewhere like down right there. So there's our function, and then all we do is we connect, sorry. Man, this is bad for him. Connect all those. Okay. And put our arrows on it. Okay. It says describe end behavior. Okay, so hopefully this will make sense. We did it in the lesson. How does end behavior work? You have two different types. Okay, you've got as x approaches positive infinity, and then you have as x approaches negative infinity. Y will be approaching something, okay? So in this case, all you do is you trace. Positive infinity is to the right. So I get on my function, I go to the right. What's it doing? It's going down, and it's going to flatten out here on the x-axis, which is at 0, okay? So y is approaching 0. As x goes to negative infinity, I trace the function going to the left. That keeps going up. That is going to be to positive infinity. So two different behaviors. It's all about how you trace, okay? So it's flattening out here. That's why that's 0. And this is going straight up, which is why that's infinity. We'll look at another one here. So let's go to the next page. All right, problem 16. So we're doing the same thing here, okay? I'm not going to write all this down. A is -5. That's our 0 term or our y-intercept. B, here's 2, okay? Now, before we go into this problem, just using points, I want us to think logically again about graphing and transformations and how we've done all this, okay? So let's talk about what's a negative do. It reflects it. So typically, if this were bigger than 1, my function would be increasing, going up. But because I've multiplied it by a negative, it's going to be flipped and go down. So my function should be doing something like this. Now, what's the 5 do? The 5 vertically stretches it. That makes it go up even faster. So what's going to happen? It's going to go down really fast, again, because it's negative. Now, if this had been something less than 1, then my function would have been decreasing here, multiplied by negative. It means you flip it, which means it would have been something like that, okay? So just use some common sense here, but again, you can go straight to your calculator, so go to y equals, type in your function, -5, parentheses 2 raised to the x, go to your table, find some values that you can plot real easily here. So again, pay attention to your x-axis. They're going by halves here. So at -2, I've got -1.25. So at -2, -1.25. So something maybe like right there. Then at -1, I have -2.5. So at -1, -2.5, so maybe like right there. Then at 0, I'm at -5, which would be somewhere like right there. 1, I'm at -10. So, because my y-axis is going by 3.5, so it'd be like right there. And then, let's see, 2, I'm at -20. So I'm going to have to move this up a little bit. 2, I'm at -20, so I'm like right there. So that pans out, kind of like what I said, okay? Now let's do our end behavior. X goes to the right, positive infinity, trace it. As it goes to the right, what's happening? It's going down to negative infinity. So y is going to negative infinity. As x goes to the left, negative infinity to the left, so trace it going to the left. This flattens out again, and it's approaching the x-axis, which is 0. Now, let me go ahead and tell you a little hint here. Because our original function was not shifted at all, I'm not adding or subtracting anything in here. I'm not shifting it up or down. That means in behavior will always be some sort of infinity and 0. The only way it cannot approach 0 for one of these is if it's been moved up or down. And remember, to move it up or down, it's not with the x, so I would have to add or subtract something. So there's nothing being added or subtracted here. So one of the approaches has to be to 0, then the other one is going to be some sort of infinity, either going up to positive infinity or going down to negative infinity, one or the other. All right, last one. State the domain and range of each function. Make sure to provide these answers using inequalities. Okay, using inequalities. So this takes us back a little bit, which is a good review for us here in terms of how to write things. So domain. What have we said for the domain of every function in Algebra 1 unless it's a word problem? Domain is all real numbers, okay? So that means the domain for all of these, A through E, would be exactly the same. So you write domain such that x is negative infinity to infinity. That's how you would write domain using inequality notation. Now, how do I get range? Now, one way is to look at your graph. Now, remember, your range, what I just said in the previous problem, that's your y value. It's going to be something at 0 to either infinity or negative infinity, but it's all about how the graph goes. Now you can graph it in your calculator and look, or also just use common sense. Sorry about that. So let's think about this. 2, that means it's got to be increasing, okay? That means it's got to be going up. That means it's going from 0 up to infinity. Now, if you were to graph this in your calculator, here's what you would look at. You would see a graph that looks something like that. So what's my range for this particular problem? My range for this one is, so they're using f of x, so I don't put y, f of x, such that what's happening? F of x is greater than 0. Now again, it never gets to 0, it just kind of flattens out there, but it's going up, so therefore it's greater than 0. Let's look at the next one. 0.4. 0.4 means it's got to be going down. That means it's decreasing like this. That means it's flattening out at 0, but what else? It's still going up to infinity this way. So my range for this one is exactly the same as this one, okay? This one, however, is different, okay? So let's think again. 0.6, that means it would be going down, but because I multiply it by a negative, that means it flips it. So instead of going like this, it goes like this. So here's what it would normally look like. But because I flip it, it goes like that. So now what's happening? This is going to negative infinity. That's still at 0. So now my range changes for this. My range for C would be f of x such that f of x is less than 0 because it's going down to a negative infinity.